In this episode, we are going to look at determinant of matrix. So now we know how to do the operation, being it addition, subtraction of or multiplication of a matrix. So let's look at how we can find the determinant of a matrix. So before we can find the determinant of a matrix, the matrix should be a square matrix. A square matrix. We know a square matrix in the form a 2 by 2 or a square matrix in the form a 3 by 3 matrix. But in this episode, we are going to find the determinant of matrix for a 2 by 2 matrix. In the next episode, we will deal with a 3 by 3 matrix. So assuming we have a matrix A with the members being A, B, C, and D, being a 2 by 2 matrix, how do we find the determinant of this matrix? We know that this diagonal is what we call the principal diagonal, and this is what we call the minor diagonal. Are you okay? So the minor diagonal. So in a situation where we want to find the determinant of A, it can be written as, so determinant of A, determinant of A is also written as delt A. So when you see find delt A, meaning determinant of A, and that is given by the formula. Anytime you want to find the determinant for a 2 by 2 matrix, the formula is the product of the major diagonal. So we are going to find the product of major diagonal or principal diagonal minus the product of the minor diagonal. Very simple. So delt A is giving us the major diagonal, which is AD. So product AD minus the product of the minor diagonal, which is BC. So in any case where you are to find the determinant of a 2 by 2 matrix, this is the formula. The product of the major diagonal minus the product of the minor diagonal. And we write the determinant of A as delt of A. Let's look at some parameters. If after calculating for delt A and we get 0, meaning the matrix is a singular matrix, put in mind, and after delt A or delt of any matrix, we are using A to represent the matrix instead, is not equal to 0, any number apart from 0, meaning the matrix is non-singular. Are you okay? Alright, so after calculating, you are going to get a value. Remember, the determinant of a matrix is a value, not another matrix. So let's look at some properties of determinants, of the determinants of the delt. Anytime we have a matrix, say we find delt of A, it is equal to delt of A transpose. The determinant of a matrix A is equal to the determinant of its transpose. Let's check. So we have a matrix A, say 1, 2, 3, 4, and its transpose, which is A transpose. You replace the column to the rows, which is 1, 3, 2, 4. This is the delt. And we are saying this is the transpose matrix. The delt of A, determinant of A, is going to be our determinant of A is going to be the product of the major diagonal, which is 4 by 1, minus the minor 3 by 2. And this is going to be 4 minus 6. And the answer is negative 2. We are saying delta of A is equal to its transpose. So delta of A transpose is going to be 4 by 1, which is the major diagonal, minus 3 by 2. The same thing, 4 minus 6, and that is negative 2. So the determinant of a matrix is equal to the determinant of its transpose. Then also, the determinant of a product matrix AB is equal to delta of the individual matrices. Are we okay? So when we find the product of AB, say we have A as matrix 1, 2, 3, 4, and we have B as 0, 1, negative 1, 1. After finding AB and you find the delta, it is going to be equal to finding the individual determinants. We will solve examples and we will see how best this is true. So let's take some examples. So example 1. Let's find the determinants. Let me use the delta of B such that this matrix B is negative 1, 2, 3, and 10. This is the matrix. So we know that delta of matrix B is going to be equal to, let's assume this matrix in a form A, B, C, D. And the delta is going to be the product of the major diagonal minus the minor diagonal BC. So looking at this, delta B is going to be negative 1 by 10 minus BC, which is 3 by 2. And this is going to give us negative 10, negative 6. So the determinant is going to be negative 16. So the determinant of this matrix B is negative 16. It's just a single number. Are we okay? So let's look at this example 2. Find the determinant of matrix A such that A is equal to 5, 2, 1, 0. So the same way, our solution, determinant of A, which is AD minus BC, and that is going to be the major diagonal 5 by 0, 5 multiplying 0 minus BC, 2 by 1. So 5 by 0 is 0 and 2 by 1 is 2, but we have negative, so the answer is negative 2. Determinant of this matrix is negative 2. Are we okay? Let's look at another example. Find the determinant of matrix AB. Check, this is matrix AB. If we are given matrix A as 1, 2, 0, 1 this way, and matrix B is given us 0, 4, 5, 5. So we are going to find delta of AB. Remember, we said delta of AB is equal to finding the individual delta and multiplying them. How we go? So we'll try and see if this is true. So first, let's find for delta of AB. But before that, let's first get AB. That's the multiplication of matrix A and B. And that is 1, 2, 0, 1. Multiplying the matrix 0, 4, 5, 5. So we've already tackled multiplication of matrices after the, so this is going to multiply that, and we are going to say the answer is going to be 0 plus 10 here. This is going to be 4 plus 10, and that will be 0 plus 5. You can check out for the multiplication approach and get why we are getting this. So this matrix product will be 10, 14, 5, and 5. That is matrix AB. So let's try to find the delt of AB. Delt of AB, where AB is given as this matrix, and that will be AD minus BC, major diagonal, that is 10 by 5, 10 by 5, and BC, minor diagonal, 14 by 5. And this, if you solve this, you are going to get your answer as negative 20 for that. Are you okay? So the determinant for the product is negative 20. Let's try to find the determinant of each matrix. So doing for delt of A alone, matrix A, that is going to be 1 by 1 minus 2 by 0. And the delt of A is going to be 1, because this will run to 0. 1 by 1, 1. Let's try to say delt of matrix B, which is major diagonal minus, so this will be 5 also by 0 minus 4 by 5. This will run to 0, giving us negative 20. So the product of delt A, delt B is going to be 1 by negative 20, and that is negative 20. So you can see that delt of A multiplying delt of B is the same as that. So this holds. This identity delt AB is equal to delt of A, delt of B. So in a situation where you cannot do the multiplication, you can just find the delt of the individual matrix, then you find the product. Thank you for watching this episode. We come your way with the determinant for 3 by 3 matrix.